The study of motion is fundamental to an understanding of physics. The study of motion comprises three different parts. The first is position, such as where this cart is. The second is velocity. If I take this cart and I move the cart, how fast does its position move from here all the way over to here? The third component is the acceleration. The acceleration explains how fast the cart changes its velocity. So if my cart is moving like this, and I suddenly stop it, the cart undergoes an acceleration because its velocity has changed.
The position of a particle is usually measured from a reference point. This is called the origin of the coordinate system. Below, we can see a coordinate system with the origin marked as 0. In one dimension, this system has two directions, to the left and to the right. Over here, we see this arrow denotes the positive direction, to the right, whereas the negative direction is to the left. The positive direction does not always have to point to the right. Direction is not set in stone. You use which direction is the most convenient for you. Let's put Bob on the coordinate system. His position is positive 2 meters, or just 2 meters. Jane's position is at negative 3 meters. The negative sign is important. We can quantify this as x of Bob is 2 meters, and x of Jane is negative 3 meters. If Bob moves over to where Jane is standing, we can say that Bob has undergone a displacement. The displacement is defined to be the difference between the final and initial positions. It's called delta x. Whenever you see one of these capital delta symbols, it always represents a change between a final and an initial state. If we put the numbers in, we see Bob has a displacement of negative 5 meters. The negative sign represents the direction that Bob moved, and the 5 meters represents how far Bob moved. If Jane instead moves to where Bob was initially standing, her displacement is positive 5 meters. She moves the same distance, but in the opposite direction. To talk about velocity, let's have Jane throw a paper airplane at Bob. Velocity is the measure of distance per time, or delta x over delta t. If we expand out our deltas and then plug in our numbers, we find the velocity of our paper airplane is 3.3 meters per second. Like displacement, velocity has a direction too. Both of these paper airplanes are traveling in different directions and have different velocities. Velocity points in the same direction as displacement. Speed, on the other hand, does not have direction. Both planes have the same speed. As we explore deeper into physics, we will find that there is a difference between average and instantaneous velocity. Average velocity measures the velocity between two endpoints, from start to finish. Instantaneous velocity, on the other hand, measures the velocity at a single point in time. The book uses lowercase deltas to represent a very small change in position over a very small change in time. In calculus, the instantaneous velocity is the derivative of the position with respect to time. To talk about acceleration, we have to talk about a change in velocity. This car slows down from 25 meters per second to 15 meters per second. The change in the velocity is negative 10 meters per second. At 0 seconds, the car's velocity is 25 meters per second. At 5 seconds, it's 15 meters per second. The acceleration of the car is the change in velocity over this change in time, or negative 2 meters per second squared. Like velocity, acceleration also has a direction. The direction of the acceleration is always in the direction of the change in velocity. So if my initial velocity is 3 meters per second and my final velocity is 5 meters per second, the direction of the acceleration points in the direction of my velocity. But if we switch it, and my initial is 5 and my final is 3, the acceleration would point in the negative direction.